Hi everyone, what's up? Welcome back to my tutorial channel. Daniel's here and today I'm gonna continue working on frequently used continuous distribution. So last video we talked about the first four continuous distribution: uniform, normal, exponential, and gamma. Today we are going to finish the last five continuous distribution: Burrito, beta, log normal, chi-square, and Weibull distribution. So let's start off with Burrito distribution. So the PDF of a two-parameter Burrito distribution is f of x with two parameters alpha and theta is alpha theta to alpha over y plus theta to the alpha plus 1, and the domain of this function is y is positive, 0 to infinity. The expected value of this distribution is theta over alpha minus 1, and the variance is alpha theta squared over alpha minus 2, alpha minus 1 whole square. The PDF of a single parameter Burrito distribution is f of x given two parameters alpha theta is alpha theta to the alpha, z to alpha plus 1, and the domain is z is greater than theta. The expected value of this single parameter Burrito distribution is alpha theta over alpha minus 1, and the variance is alpha theta squared over alpha minus 2, alpha minus 1 whole square. So from the two parameter to the single parameter, the expected value of the single parameter is obtained by multiplying the expected value of two parameter Burrito distribution with alpha, and we have the same variance. The relationship between z and y is z is y plus theta, and the graph of the two parameter and the single parameter Burrito distribution can be obtained by shift the graph to the left and to the right. So from two parameter Burrito, we can obtain the single parameter Burrito by shift to the right theta unit. So here alpha is 1, theta is 2. This is also alpha is 1, theta is 2. So the when we shift the graph of two parameter Burrito to the right 2 units, we obtain the single parameter Burrito density graph. And from the first graph to the third graph, we see when alpha increases, the graph becomes more peak at 0. So there are two commons here. As alpha increases, the PDF of two parameter Burrito distribution becomes more peak at 0. The one parameter Burrito PDF is the same as the two parameter Burrito shifted to the right theta unit. Next, beta distribution. The PDF of beta distribution with two parameters and a and b, which are both positive, is f of x given a and b is 1 over beta ab x to the a minus 1, 1 minus x to the b minus 1, and x, the domain is from 0 to 1, and the PDF is 0 on the other intervals, where BAB here is the beta function and defined as B of AB is integral from 0 to 1 x to alpha minus 1, 1 minus x to b minus 1 dx. And in beta distribution, the expectation is alpha is a over a plus b, and variance is ab over a plus b plus 1. Actually, this distribution is quite similar to the gamma distribution. So there is a relationship between beta function and gamma function. The beta function of AB is gamma function of A times gamma function of B over gamma function of A plus B. And in some special cases, if a and b are two integers, the beta function is defined as beta function of ab is a minus 1 factorial b minus 1 factorial over a plus b minus 1 factorial. This can be proved from gamma function. Remember, if n is an integer, then gamma function of n is n minus 1 factorial. So beta function of ab is gamma function of a times gamma function of b over gamma function of a plus b. Gamma function of a is a minus 1 factorial. Gamma function of b is b minus 1 factorial, and gamma function of a plus b minus 1 is a plus b minus 1 factorial. And the PDF of the beta function when a and b are two positive integers is we replace ab by this quantity, and so that's how we obtain the beta function when a and b are the integers. And here's some graphs for some beta distribution. So when a is 2 and b is 1, the function becomes 2x, and this is a linear function. So it's a straight line passes the origin. When a is 2 and b is 2, we have the function the function 6x, 1 minus x. This is quadratic, turn downward. So this is a quadratic. When a is 4 and b is 2, we have 20x cubed 1 minus x. This is a polynomial function. And on the interval from 0 to 1, this is the graph of it. Next, log normal distribution. If W follow normal distribution with mu and sigma square, then x is a new variable defined as e to the W follows the log normal distribution with parameters mu and sigma square. And the PDF of x is 1 over x sigma square root of 2 pi e to the negative natural log of x minus mu whole square over sigma square. And the domain of this function is 0 to infinity. The expected value of log normal distribution is e to the mu plus 1/2 sigma square, and variance of x is e to the sigma square minus 1 times e to the 2 mu plus sigma square. And the CDF of this log normal distribution is capital F of x is capital phi of natural of x minus mu over sigma. And here's the graph of log normal distribution when mu is 0 and sigma square is 1. So next, Weibull distribution. The PDF of Weibull distribution is f of x given tau and theta is tau times x over theta to the tau, e to the negative x over theta to the tau over x, where x is positive, and the CDF is 1 minus e to the negative x over theta to the tau. One thing we should notice here is if tau is 1, we have this is x over theta, e to the negative x over theta, and we obtain x with x cancel to obtain the exponential distribution. So basically, exponential distribution is a special case of Weibull distribution. And here's how the graph of Weibull distribution with two parameters, tau is 2, theta is 0.5 looks like. The last distribution of today is chi-square distribution. So chi-square distribution is basically a special case of gamma distribution. So to understand chi-square distribution, we recall gamma distribution. Remember, there are two versions of gamma distribution depending on how you make notation. So here I'm using gamma distribution f of x given alpha beta is 1 over gamma function of alpha beta to the negative alpha e to the negative beta x to the alpha minus 1. and here x is positive. The chi-square distribution with parameter k is a special case of gamma distribution when beta is 1/2 and alpha is k over 2. So we are going to substitute beta by 1/2 and alpha by k over 2. So f of x given k is 1 over gamma function of k over 2 times 1/2 to the k minus 2 e to the negative x over 2 x to the k over 2 minus 1, where x is positive, and k here is called the degrees of freedom of chi-square distribution. And there's one about the expectation of x follow gamma distribution is alpha over beta. So we have k over 2 over 1/2, which is k. Variance of x is alpha over beta whole square, so that's k over 2 over 1/2 whole square, and we have 2k. The moment generating function is 1 over 1 minus 2t to the k minus k over 2, where t is less than 1/2. And there's a very important notice about chi-square distribution, that is, if z1, z2 to zn are n independent standard normative random variables, then x is defined as the sum of square. That means z1 square plus z2 square plus zn square follows chi-square distribution with degrees of freedom n. This is a very important notice in chi-square distribution. And here's how the graph of chi-square distribution look like. So for exam P, it is important to be familiar with uniform, normal, and exponential distribution in continuous cases. It may be helpful to have some familiarity with the Pareto and beta and gamma and log normal distribution, but actually on exam P, usually the question falls into a uniform, normal, and exponential distribution. So that was everything about continuous distribution. Now we're going to do some practice, and because on the exam we focus mainly on three distribution: exponential, uniform, and normal. So I'm gonna practice on those three distribution. Problem number 1. An insurance company sells two types of auto insurance policies, basic and deluxe. The time until the next basic policy is an exponential random variable with mean 2 days. The time until the next deluxe policy is an independent random variable with mean 3 days. Where is the probability that the next claim will be deluxe policy claim? So here we see that, let's say x1 is the time until the next basis policy, and x2 is the time until the next deluxe policy. So here x1 and x2 are both exponential random variables. E of x1 is 2 and E of x2 is 3. And the question is, what is the probability that the next claim will be deluxe policy? That means probability that x2 is less than x1, because if the time to the next deluxe policy is less than the time to the next basic policy, deluxe will occur first. So for the basic policy, the time until the next basic claim is x, and x follow f of x. This is exponential function. For deluxe policy, the time until the next deluxe claim is y, which is 1/3 e to the negative y over 3. The probability that the next claim is deluxe is probability that y is less than x. So to do this problem, we need something called a Chon PDF. Actually, this problem should be given after lesson 8 and 9, but I include here because it's related to exponential distribution. Don't worry if you don't understand this solution, because after lesson A, you will be able to know what is the shown PDF of x and y. So here, because x and y are independent, so the shown PDF is basically we multiply the two PDF together. So h of xy is f of x times cube y, and we have 1/6 e to the negative 1/2 x minus 1/3 y. So probably y less than x. This is a double integration. So here both x and y are positive, but y is less than x. So we are going to keep x first and work with y. So the domain of y depends on x is from 0 to x, and the domain of x is 0 to infinity. So probably y less than x is integrate from 0 to infinity, integrate from 0 to x of the shown PDF, and dy dx, and which is 1/6 integral from 0 to infinity e to the negative x half minus 3 e to the negative y over 3. Y go from 0 to x. So I finish the inner integral. And after I finish the integral, I have a single integral from 0 to infinity e to the negative x half times negative 3e to the negative x third plus 3. And this become 3 with 3, negative 3 with 1/6 becomes negative 1/2. And this is integrate from 0 to infinity e to the negative 5x over 6 minus e to the negative x half, and finish this integration. We have the answer is 0.4. Problem number 2. For company A, there is a 60% chance that no claim is made during the common year. If one or more claims are made, the total claims amount is normally distributed with mean 10,000 and standard deviation 2,000. For company B, there is a 70% chance that no claims are made during the common year. If one or more claims are made, the total claims is normally distributed with mean 9,000 and standard deviation 2,000. Assume that the total claim amounts of two companies are independent. What is the probability that in the common year, company B total claim amount will exceed company A total claim amount? So here, many people will got trapped by this problems because they forgot one case, that is if there's no claim in company A and there is a claim in company B. Basically, B already exceeds A. So for this problem, we have to separate into two cases. The first case is when there's no claim in company A and there is at least one claim in company B. That's the first case. The second case is when there is at least one claim in company A and at least one claim in company B. Then we have to work with normal distribution. So here company A, XA, in case there is at least one claim, XA follow normal 10,000, 2,000 square, and company B, XB follow normal 9,000, 2,000 square. When both two companies have claims, that means when A, here I notate A greater than 0, that means there's at least one claim in company A, and B is greater than 0 means there's at least one claim made in company B. So I set y equal to xb minus xa, and this follow normal naive 1000 because I take 9000 subtract 10,000, which is naive 1000. Then for the variance, basically I add the two variants together, so 2000 squared plus 2000 squared. So to find the innovation, I take the square root of this variance. I have 2000 square root of 2. The mu is naive 1000. So now the probability that B exceeds A is, we have two cases. The first case is there's no claim in company A, and there is at least one claim in company B. So in this case, B is already exceeded A. So the second case is when both company has at least one claim in the common year. So we have probability A positive, B positive, and XB minus XA is positive. So the first case, the probability that there is no claim in company A is 0.6. The probability that there is at least one claim in company B is 0.3. The second case, the probability that there is at least one claim in company A is 0.4. The probability of there's at least one claim in company B is 0.3, and the probability that B exceeds A is 0.363 because probability of XB minus XA positive is probability that Y is positive, and use standardization. We have probability is Z, which is Z is the standard normal distribution, standard normal random variables. So Z greater than 0 minus naive 1000 is plus 1000 over 2000 square root of 2. So that is 0.363, and we plug in here. So the answer of this question is 0.223. 0.223 is the answer. Problem number 3. The waiting time for the first claim from a good driver and the waiting time for the first claim from a bad driver are independent and follow exponential distribution with mean 6 years and 3 years respectively. Where is the probability that the first claim from a good driver will be filled within 3 years, and the first claim on a from a bad driver will be fired within 2 years? So here, let's say X1 is the waiting time for the first claim from a good driver, and X2 is the waiting time for the first claim from a bad driver. So we have X1 and X2 are independent, and they are both exponentially distributed. So good driver X follow f of x is 1/6 e to the negative x over 6. Bad driver y follows u, y, which is 1/3 e to the negative y over 3. And the probability that the first claim from a good driver will be fired within 3 years and the first claim from a bad driver will be fired within 2 years is probability that x less than 3 times probability that y less than 2, because they are independent. So remember the Cdf function. The Cdf is 1 minus e to the x over lambda. So this is x is 3. So 1 minus e to the negative 3 over 6 times 1 minus e to the negative 2 over 3. And the answer is 1 minus e to the negative 1/2 minus e to the negative 2/3 plus e to the negative 7/6. So that's problem number 3. So now problem number 4. Two instruments are used to measure the height h of a tower. The error made by the less accurate instruments is normally distributed with mean 0 and standard deviation 0.0056h. The error made by the more accurate instrument is normally distributed with mean 0 and standard deviation 0.004h. Assuming the two measurements are independent random variables, what is the probability that the average value is within 0.005h of the height tower? So here I must say x1 is the error made by the less accurate instrument, and x2 is the error made by the more accurate instrument. So x1 follow normal 0.0056h square, and x2 follow normal 0.0044h square. So the average of the error should follow normal 0 sigma square, where sigma square is the sum of the two, and the average we divide by 4, and then we take square root for the standard deviation. So sigma here is 0.00356x. So the probability that the average value is within 0.005x is probability that x bar absolute value less than 0.005x. So that means x bar is between negative 0.005h and 0.005h. And use standardization, we have phi of 1.4 subtract phi of negative 1.4. So the answer is 0.838, which is around 0.84. So the answer is D. The last problem, suppose the continuous random variable x has a density function. F of x is gamma function of a plus b over gamma function of a times gamma function of b, x to the a minus 1, 1 minus x to the b minus 1, where x is between 0 and 1, a and b are both positive. So if b is 6 and a is 5, what is the expected value of 1 minus x to the negative 4? This is beta function. Remember, if 6 is if beta is 6, an integer, then gamma function of b is 5 factorial. Gamma function of a is 4 factorial. A plus b is 11, so gamma function of 11 is 10 factorial. So when b is 6 and a is 5, we have f of x is 10 factorial over 5 factorial, 4 factorial, x to the 5th, 1 minus x to the 4, which is 1260 x to the 5th, 1 minus x to the 4. And to find the expected value of 1 minus x to the negative 4, we basically integrate from 0 to 1 of 1 minus x to the negative 4 times f of x. Here 1 minus x to the negative 4 cancel out with 1 minus x to the 4. So this becomes integral from 0 to 1 of 1260 x to the 5th. So finish this integration. We have 1260 x to the 6 over 6 from 0 to 1, and the answer is 210. So that is everything for today. Thank you so much for watching my video, and I hope you guys enjoyed my lesson.